Ever looked at the world and thought, yeah, I get how things work? Prepare to have that notion shattered. We're diving into scientific phenomena that defy common sense. This is real science that pushes our understanding. Science can be weirder than fiction. Here are 10 experiments that'll make you question reality. Liquids you can walk on, objects defying gravity, and glowing beaches. Each experiment is a testament to the universe's surprises. These discoveries rewrite textbooks and remind us there's always more to learn. Stick around for all of them, especially our number one pick. It's mind-bending. Wait till you see number one. It's like science fiction happening now. Buckle up, engage your curiosity, and get ready for a journey into the wonderfully weird. Like and subscribe for more crazy science. You won't want to miss what's coming next. Imagine stepping onto a surface so incredibly hot, or in this case so incredibly cold, that it should instantly cause severe damage. Yet, under the right conditions, you can. Or, more practically, imagine a droplet of water skittering across a searing hot pan, seemingly floating, almost dancing, refusing to boil away immediately. This isn't a trick of the eye. It's a fascinating phenomenon known as the Leidenfrost effect. We're going to explore how this seemingly impossible feat, like walking on liquid nitrogen, don't try this at home, is made possible by a surprisingly simple yet elegant physical principle. Picture this, a superconductor cooled to low temperatures hovering above magnets. It's not just floating, it's locked in place. You can nudge it, spin it, and it stays there, fixed in space. This is quantum locking, or flux pinning, a striking demonstration of quantum mechanics. Imagine standing on a beach at night and with every step you take, the sand beneath your feet explodes in a shower of ethereal blue light. Or picture the wake of a boat, not just churning water, but leaving a trail of shimmering, otherworldly luminescence in the dark sea. This isn't a dream, nor is it pollution. This is bioluminescence, a natural phenomenon where living organisms produce and emit light. One of the most common and spectacular displays comes from tiny marine organisms, often dinoflagellates, a type of algae or plankton. But how do these microscopic life forms create such a dazzling spectacle? Have you ever seen someone run across the surface of a liquid or punch a pool of what looks like milk, only for their fist to stop as if hitting a solid? This isn't a superpower, it's the fascinating world of non-Newtonian fluids. Unlike familiar Newtonian fluids like water or oil, which have a constant viscosity or thickness, regardless of the stress applied to them, non-Newtonian fluids are rebels. Their viscosity changes dramatically when you apply force. The most famous example you might have seen or even made is oobleck, a simple mixture of cornstarch and water. Imagine a ping-pong ball, light and fragile, fired at speeds so high it can punch through aluminum cans, or even wooden paddles. The secret? Air pressure, or rather, a vacuum. A vacuum cannon shows atmospheric pressure's power. A long tube sealed with breakable membranes and a ping-pong ball inside. Suck out the air, creating a vacuum. You've probably seen them in science museums, novelty shops, or maybe even in an old sci-fi movie. A clear glass sphere with a central electrode from which vibrant tendrils of colored light snake outwards like miniature lightning bolts trapped in a bottle. If you bring your hand close to the glass, these tendrils leap towards your fingertips, seemingly drawn by your touch. This is a plasma globe, and it's not just a cool visual effect, it's a beautiful demonstration of plasma, the fourth state of matter. Imagine a black, oily liquid that, in the presence of a magnet, transforms. It doesn't just move, it erupts into an array of intricate spikes, flowing and reforming into mesmerizing, almost organic patterns. It can climb surfaces, create bridges, and dance in ways that seem to defy gravity and logic. This is ferrofluid, a truly remarkable material that beautifully visualizes the invisible forces of magnetism. It looks like something from a sci-fi movie, a sentient alien ooze, but its secrets lie in clever nanoscale engineering. We're all familiar with the three common states of matter: solid, liquid, and gas. Water can be ice, liquid water, or steam, but what if I told you there's a state that blurs the lines, a substance that can behave like both a liquid and a gas simultaneously? Welcome to the weird world of supercritical fluids, and a prime example is supercritical carbon dioxide, CO2. Imagine heating CO2 in a sealed container above a specific temperature and pressure, its critical point. As it approaches this point, something extraordinary happens. The meniscus, the clear boundary between the liquid and gas phases, simply vanishes. Here's a classic science prank that never gets old, but also beautifully demonstrates a fascinating material property. Imagine handing someone a normal-looking metal spoon to stir their hot tea or coffee. They stir, and to their astonishment the spoon starts to melt and droop as if it were made of chocolate. What's going on? Is it a magic trick? Not quite. The spoon is made of gallium, a metal with an unusually low melting point. Gallium is solid at room temperature but melts at just 29.76 degrees Celsius. This one, folks, is where reality really starts to feel like it's bending. We're familiar with regular crystals, like salt or diamonds. Their atoms are arranged in a repeating pattern in space. But what if a material could repeat its structure in time? This mind-boggling concept is called time crystals. Theorized by Frank Wilczek in 2012, they represent a new phase of matter. So there you have it, 10 glimpses into the astonishing world of science. From liquids that defy gravity to matter that keeps time on its own, our universe is packed with wonders. Time crystals, a state of matter with periodic motion in its ground state repeating in time. It sounds like a physicist's dream or a sci-fi show. What other aspects of reality have we yet to discover? These experiments are windows into the fundamental laws that govern everything.